Welcome to the Textures in Clay Additive Manufacturing Workshop, an initiative exploring the potential of creating sustainable and unique textured forms using clay 3D printing. Our objective here was to fully exploit the collaborative potential of texture as a characteristic and 3D printing as a process through custom developed machine code manipulation techniques. By experimenting with various variables such as layer height, extrusion rate, speed, nozzle shape, we aim to generate complex patterns integrating algorithmic design to achieve different effects. During the workshop, our participants explored several research areas to further this initiative. Material study was conducted to understand the behavior of clay during printing. They also analyzed its plasticity, drying, shrinkage rate, and optimized it by adjusting water content, particle size, binder additives. Various infill patterns were evaluated for their strength, stiffness, and stability. Participants analyzed the effects of infill density, orientation, and shape on properties such as shrinkage, warping, buckling, and strength. We also explored printing walls, evaluating the feasibility of load bearing, integrating services, and insulation in the wall structure through iterative design development. Experiments were conducted on waffle slabs, their density, their size, planter pockets, and techniques of achieving them. Iterative checks were also made to find possibilities of their sizes as green walls to enhance air quality and reduce environmental impact. Organic shaped bricks using 3D printing technology were explored as a valuable add-on to existing vernacular construction methods to enhance building aesthetics while retaining sustainability and cultural linkages. Various infill structures and surface finishes were attempted during this process. To employ 3D printing clay components as a spanning element, various different techniques were explored to create a shallow dome. The output will be further evaluated for structural performance, thermal behavior, and dimensional stability to generate a more informed design that can realize clay as a sustainable material in architectural spanning elements. Stackable components with algorithmically changing patterns were designed and printed during the workshop to exploit print volume limitations and time optimization as well as responsive patterns. Through these various studies conducted during the TCAM workshop, we have sowed the seeds of exploring possibilities of creating sustainable and unique textured forms using custom developed printing techniques for clay 3D printing.